Hi guys, I hope you're all doing well at home. This is going to be our third week of school from home, so our third set of notes, third homework assignment, and we're still in our polynomials unit, and this week is going to be division. So division with a polynomial by a monomial. So poly is just that prefix for many, and then monomial just means one term. So last week what we did was multiplication, and we had a binomial multiplied by another binomial. So we had to do the FOIL method. This week we're going to just be doing division, and there is a quotient rule, which we would have talked about in the very beginning of the year when we did operations with exponents. So this will be kind of a review. You might remember doing this in the beginning of the year, you might not, but you're basically going to use subtraction when you have exponents that are being divided. So just a reminder, make sure that you take down these notes on your own paper. You don't have to set them up exactly like my paper is, but at least give them a notes title, and then any statements that we have, just copy down the statements so that you know what we're doing in this set of notes and what we're doing on the assignment. And then by the end of the week, make sure you send me or upload a picture of your notes and then a picture of your assignment. I'm giving you guys a grade for doing both. And then by the end of the week, I will post an answer key for you to check your homework answers with and see how you did. And then Fridays, we have that optional Google chat, the Google Hangout, if you have any more questions that you want to ask me. But feel free to email me or text me on Remind during the week if you are stuck on anything. I am here to help. So let's get going with this. And then after this video is posted, I will post a picture of your assignment. So the sentence that I need you to copy down is what we're doing when we're dividing here with polynomials. So dividing a polynomial by a monomial is basically dividing everything in the numerator by the term in the denominator. And then for exponents, you have to use the quotient rule. So this is something a little different. Now you have to have the same base, all right? You have to be working with the same letters. So if some term up here had an X and then another term down here had a Y, well, those are different and they have different bases, so you wouldn't be able to do this with the exponents. But as long as you've got the same letter, if they have exponents, we'll just call those exponents A and B, okay? X is the same, so we can go ahead and subtract whatever the exponents are. And when you subtract, order does matter with subtraction, so make sure you're taking the exponent in the numerator and subtracting the exponent in the denominator, okay? Whatever the variable is, that's going to stay the same. So let's do an example here. We've got example 1. Now it says up here, divide the coefficients, all right, divide the term in the numerator by the term in the denominator. So the division is going to come from the numbers in front, okay? These coefficients, these numbers that are in front of the letters. Now we've got the same letter, letter N, so we can go ahead and subtract the exponents, but we are going to divide the numbers in front of our variable. So what this first example looks like, if I were to break this up, is you have an 8n squared. That's one term. And it says up here, divide everything in the numerator by the term in the denominator. So we're going to take that 8n squared. I'm just breaking up the problem that we have, and you're dividing it by 4n. The other thing you're going to divide is the 36n by 4n. Okay, that'll be a minus in front of it, so that's 36n divided by 4n. Okay, I'm not just making up another 4n, I'm just showing you that both of these terms in the numerator have to divide by the denominator. So if I take an 8, I'm just going to look at this first part. If I take an 8 divided by a 4, you get 2. Now the quotient rule says that when we've got the same base, which in this case is an n, you subtract their exponents. So this exponent after the n is a 2, and even though we don't see 1 here, we assume it's a 1. So 2 minus 1 would just be 1. And again, you can write that 1 in, or you can just leave it as 2n. All right, now let's do the second part. We've got a 36 divided by a 4. So that's going to give us 9, but that negative sign is in front of it. So this is the same as doing negative 36 divided by positive 4. So that'll give us minus 9. Now getting back to the exponents, all right, we're going to use subtraction. And since we don't see an exponent, we're going to assume that each of these n's have a 1 after it, just like we did down here in the first part. Now, if you take 1 minus 1, obviously you get 0. So anything to the 0 power is 1. Okay, so we don't write n to the 0 power because it's just going to be 1. 9 times 1 is 1. So we're just going to leave that as a minus 9. We're not even going to write the letter n after it because it would be n to the 0 power if we did. So that's our final answer. That's division of a polynomial by a monomial. Now let's look at this one next to it, example 2. It's got a little bit more to it. So we have two variables, but we have an x and a y, okay? Every term in this problem has an xy, okay? xy, xy, xy. So even though it's two letters, they are still all in the same term. Like this 7x squared y squared is one term. This negative 14 x to the 12th y to the 5th, that's one term. And then this 7x squared y squared is one term. So all three of these terms have an x and a y. So we can use this subtraction rule because the base is the same letter. So what we have really is two division problems. We have these being divided, and then we have these being divided. Remember, it says take each term in the numerator and divide it by whatever's in the denominator. Okay, so let's start with this negative 14. Let's do our division first. If I take negative 14 and divide it by 7, I get negative 2. Okay, we have xy, so we can go ahead and use our subtraction rule. All right, so for the x's, you've got a 12 up here and a 2 down here. So that leaves you with x to the 10th. 12 minus 2 is 10. Now let's look at the y's. We've got a 5 over a 2. So 5 minus 2 would give us 3. All right, that's the first part. Now we have to do this second division. Okay, if I take the number in front, 7 divided by 7, I just get 1. Now the other thing you have to remember is you don't usually see the 1 written in front of a letter. It's just assumed if it's out front. So I'm not going to write a 1. I'm just going to see what I get after I subtract with the x's and the y's. Okay? So if I take the x's, 2 minus 2 are the exponents, and for the y's, it's 2 minus 2. So here's what we would get. And remember, we got 1 from doing 7 divided by 7. So this is what we have. Now remember, anything to the 0 power is 1. So what this is really saying is 1 times 1 times 1. So from this whole division right here, all we got was 1 from all of this. So our final answer is just putting that 1 at the end. Okay, so there's our first two examples. Let's do a few more before I stop the video and then post this along with your homework. So let's go down here where it says just number 1. All right, find each quotient. So it wants you to divide. Quotient is the answer to a division problem. Now, we only have an x right here. That's our variable. So we don't have to worry about making sure these other terms have an x because they don't have a letter at all. But we still have to divide. All right, you can do 6 divided by 3 because the 3 doesn't have a letter at all. It doesn't have a letter to match. So 6 divided by 3 would be 2, and the x just stays because there were no exponents, there's no x down here to do any subtraction or division with. So let's look over here. We've got a 9 divided by a 3. So here's our two problems that we're doing. 9 divided by 3 is 3. So that one was pretty quick. 2x plus 3 is our final answer. All right, let's do number 2. So same thing. This is just a 5 down here. So every one of these 3 terms up here is just getting divided by 5. Okay, so 10 divided by 5 gives you 2. And then the v squared, just like the x in the first problem, has nothing to do to subtract by down here. So it just stays v squared. Same thing here. You have a 5 divided by a 5. That gives you 1. And then the v just stays. So we're going to add that because it's positive. Now you could write 1v, or you could just write v. And then the last thing is negative 15 divided by 5, which gives you a negative 3. Okay, so there's the second one. Let's go down here to 3 and 4, where we actually do have a variable. We have a letter in the denominator. So we're going to divide these. We've got 3 things there. Okay, so we're doing technically an 8 divided by a 1 there. All right, we're not going to write the 1 because usually you don't, but we do have some exponents to subtract. We have a to the third over a to the first. So if you do 3 minus 1, you get 2. Okay, 8 divided by, there's also an imaginary 1 in front, would just give you 8. Okay, now let's see what we got in the middle. We've got a negative 2 divided by 1, which gives us negative 2. And then our exponents are a 2 minus a 1. Okay, so you could write a to the first, or you could just leave it like that. And then the last thing is just a 5a divided by a 1a. Okay, so what we would get when we do 5 divided by 1 is just 5. And then we have a to the first minus a to the first. So when we have 0, that just equals 1. So 5 times 1 is just 5. Okay, let's go over here to number 4. First thing we're doing is, looks like we've only got 2 things to divide. 40 divided by 8, so that gives us 5. Our exponents for our variable x is a 2, and we're subtracting a 1, so that just gives us x to the first. The last thing is negative 8 divided by 8, which gives you a negative 1. And then again, we've got x to the first minus x to the first. So anything to the 0 power is 1. So 1 times negative 1 keeps it as a negative 1. Okay, let's move on to these down here. So number 5, we have 3 terms to divide by 3c. Okay, so we've got 18 divided by 3, which gives us 6. Now the c's have a 3, move this up, minus a 1. Okay, so when you do 3 minus 1, you get 2, so that's c squared. So that's our first term. Now in the middle, you have a negative 21 divided by 3, which gets you negative 7. And then the variable has an exponent of 2 up here, minus a 1, which is just c to the first. And then down here, the last one is 3 divided by 3, which is 1. And then again, we have c to the first minus c over to the first. So again, c to the 0 power would give you 1. Okay, let's do number 6. Now our common variable here is an a and a b together. Okay, so we can go ahead and use our subtraction rule up here because we have the same variable over the same variable. So we have AB, AB, and AB. Now let's do our division first. So we have 6 divided by negative 2. So that gives us negative 3. And let's see what we have as our exponents. A squared, and then these have an imaginary 1 as their exponents. So 2 minus 1 would be 1. And then our b's is a 1 minus 1. So again, 0. That just turns into 1 and leaves this negative 3a as negative 3a. So the last term is negative 12 divided by negative 2, which is positive 6. And it looks like our a's are going to give us 1 again, because we have 1 minus 1, which is 0. Okay, but the b's have a 2 minus 1, which is 1. So the only variable that's left with that 6 is b. Okay, and I'm going to stop this here with these 8 examples. So if you need more examples, just email me, send me a text through Remind, let me know, and I could show you a few more examples. But I think this is enough to get you started on your assignment, so I'm going to stop the video here and just make sure you answer the homework questions and send these both to me by the end of the week.